Now my dear friends, this is the question number 34. This question is asked in NEET 2016, my dear friends. The compound that will react most readily with gaseous bromine has the formula. Here my dear friends, we can see the, first of all, we can draw the formulas of the C3H6 means this, what is the C3H6? It's go to the general formula, that is CnH2n. So my dear friends, when you can see the general formula CnH2n, it means it's alkene, and because here my dear friends, this n is equal to 3 to the 6, that's why it is alkene. And when we put these 3 carbon atoms in this way, then double bond is placed between the carbon and carbon. So you can here see CH and here CH2. This is the structure formula of this C3H6. Now my dear friends, when we take this C2H2 is the alkynes. 2 2s are 4. It is the alkynes, because my dear friends, in alkynes, my dear friends, it's a general formula of alkyne is CnH2n minus 2. That's why you can see here alkynes, C2H2 means carbon atom 2. That's why it is called 2. 2 2s are 4 minus 2, that equals C2H2. Means structure formula of this alkyne is CH triple bond CH. Now when we see the third compound, that is the C4H10. My dear students, it's a general formula is alkane, CnH2n plus 2. It's alkane. So structure formula of this alkane is 1, 2, 3, 4. Here CH3, here CH2. You can get here CH2. Then you can get here, my dear students, CH3. In this way, my dear students, you can see here 1, 2, 3, 4. C4H10, you can form this C4H10. Now when we go to the fourth example, it is called C2H4. C2H4 is the example of this alkene, C2H4. Now we can here draw this C2H4, that is CH2 double bond CH2. So my dear students, here 3 hydrocarbons are present, alkane, alkene and alkyne. When these 3 hydrocarbons are reacts with this bromine, gaseous bromine, now my dear students, first of all this single bond, then double bond, then triple bonds are present, and when this gaseous bromine are formed, the intermediate, that is a transition state, this bromonium ions are attached with here. So my dear students, you can see that this in this compound CH3 CH double bond CH2, in this compound here, this alkyl group is a plus I effect show. So it repels these electrons, and due to repelling of this electron, my dear friends, negative charge already, partial negative charge also develop on this carbon atom. My dear students, when this charge develop on this carbon atom, and this type of electron density not increases in this alkane, so alkane is not answer. This type of extra electron density not increase in this alkynes, only triple bonds are present. Here this unsaturation is also present in alkenes. Here this ethene C2H4, this extra electron density is not increases in ethene. So this is not answer, this is not answer, my dear friends. So you can get the answer, that is CH3 CH double bond CH2, and 3 plus 4, 3, 4 plus 2, 6. That's why you can go, the answer is C3H6. This is the correct answer, question number 34. My dear students, this question is asked in NEET 2016. So you can first of all draw the structure of these compounds, and then you can see extra electron density is increases in which compound. You can see here unsaturation is present, that's why answer is alkene or alkynes, not alkanes, because in alkanes only substitution reactions are take place. Now my dear students, when we go to the question number 35, here you can see in the reaction with HCl, an alkene reaction accordance with the Markovnikov's rule. to give a product 1-chloro-1-methyl cyclohexane. Here my dear students, you can get here product. First of all, you can draw the reaction of this compound. Here you can draw the reaction. What is the reaction of this compound? Here we can see that this 1-chloro-1-methyl cyclohexane this is the 1-methyl and here this is the 1-chloro. Here this is the first carbon atom, my dear students, 1, 2, 3, 4, 5 and 6. In this carbon atom you can see here this chlorine atom is present on one carbon atom and this methyl group is also present on one carbon atom. That's why you can see here 1-chloro-1-methyl cyclohexane is the product in this reaction. My dear students, when you can see that this product of this reaction, which of the following compounds give this product? This is the question. And this question is also asked in 2015 NEET exam. The possible alkene is, and this is the possible alkene is. Here my dear students, when this HCl is added in this alkene, you can see here, then this carbon atom or this carbon atom, Cl group attached on this carbon atom or this carbon atom. So, but this is the position of chlorine is 2 or 3 maybe. Now, we can see here that here this position of chlorine is 1-chloro. It is given in your this question. So, my dear students, answer is that here double bond is present on this carbon atom. When this HCl is added, you can draw this reaction, double bond CH2 plus HCl is added, then you can get this plus charge and minus charge. And my dear students, when you see here, this is the, here you can get this carbon atoms CH2, 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 these are repel the electrons, and because my dear students, this electron repelling due to the electron density of this chlorine, and pi electrons when goes to the here in this carbon atom, because electron density is increased, that's why these electrons go to this carbon atom. So my dear students, here positive charge is developed on this carbon atom, and when this positive charge is developed on this carbon atom, here this chlorine atom attack on this carbon atom. So you can get this Cl and H plus ions attack on this CH2. That's why you can get the CH3. In this way, you can see here when this alkenes reacts with this HCl to form, my dear students, this 1-chloro-1-methyl cyclohexane. Now, when we see this is option A, and when we see the option number B, and option number B is this one. Here double bond is present here, and here CH3 group is present. My dear students, in this carbon atom you can see here 1, 2, 3, 4 carbon atom are present. That's why you can see in this compound number B, you can see here, my dear students, no hydrogen atoms are present. Now when add this HCl plus and minus, here you can see the electronegativity of this carbon atom is more. So this electrons are moved from here this carbon atoms. So electron density of this carbon atom is more. So positive charge is developed on this carbon atom, because here electrons are repelled by these alkyl groups. So this Cl group attached on this carbon atom. So you can get this product, same product. You can go the option C, because in C option A and B both reactants are present. Now my dear students, this question is asked in 2015. I hope you can understand this concept. This is the concept and reaction. Now my dear students, when we go to the question number 36, which of the following is not the product of dehydration of? Here, first of all, you can see the concept and reaction. Concept and reaction, my dear students, here you can see the this is the OH and H. When dehydration is take place here, these OH groups are removed as a water molecule. Here OH is removed as a hydroxide ion, and from H plus ions, it reacts with H plus ions from acid H2SO4, you can use for the dehydration. So this H plus and OH minus ions form this water molecule. Here my dear students, you develop this carbocation, a positive charge develop on this carbon atom. So you can see here this carbocation is formed. Here my dear students, when this carbocation is formed, then H plus ions are removed from here in this side, or here in this side, or here in this side. Because here H plus ions are also present. Here this is the carbon atom in which CH3 group are present. Here you can see the here CH3 groups are present. So my dear students, when removal of this positive charge, it must be there. H plus ions are removed here in this side, or in this side, or in this side. My dear students, you can see the three products you can get here. When you can remove this H plus ions, then this H plus ions are removed, then electrons are go and bond are go and form in this side. So you can get this structure number 1. When this hydrogen is removed, this is the number 1 here this is number 2, and this is number 3. So my dear friends, when you remove this hydrogen atom, then you can get double bond from here and here, because this bond is come between the carbon and carbon. So this positive charge is neutralized. In this way, you can form this compound number 2. Here this is the number 2 compound, my dear friends, number 2. Here this is the number 1 compound. And when we see when we see the third hydrogen atom is replaced here, then this bond is go between the carbon and carbon, then so this double bond is formed. Here you can see this double bond is formed. That's why, my dear friends, you can form these 3 structure when removal of this H plus ions, or removal from this or from the dehydration. So you can get here A, yes, this A is not formed here. So my dear friends, question is that which of the following is not the product? So you can go to this answer A, because you can, this compound is also formed. Here you can put this bond here, because here one bond is also present. So my dear students, here A is not obtained. B, you can see here B is obtained, you can see here C is obtained, you can see here D is also obtained, but this A is not obtained. So my dear students, this is the question number 36. I give you concept and reaction. I hope you can well understand these questions, because it's important questions, and this question is also in NEET 2015. Now my dear students, we can see here question number 37. In the following reactions, CH3C, CH3, CH3, CH double bond, CH2 is reacts with this water and H plus ions to form A and B. My dear students, it's a very important questions, because the major product is here conversions occur. You can see the concept and reaction for this question. Concept and reaction. My dear students, when you see here this compound and this compound, this H plus ions are added. First of all, you can see when this electrons go to in this side, minus and plus is formed, and this H plus ions add this compound here. Then you can form the first compound, that is CH3, C, CH3, CH3, here CH plus charge, and this is CH3. This carbocation is you formed. Now this OH groups, here you can get the H plus ions and OH minus ions from water. Here my dear students, OH group is attached to here. This is a simple reaction, and I hope you can add this OH minus ions. But my dear students, this question is asked in NEET exams, so some here interesting things are occur, because here this is a secondary carbocation. My dear students, I earlier say you, when secondary carbocation is present in the molecules and if rearrangement may occur, then rearrangement must be there. So here my dear students, rearrangement is occur, and due to this rearrangement, this secondary carbocation is converted into tertiary carbocation. This methyl group is this methyl radical minus radical go from this with this bond and attach this carbocation. So this is a shifting of methyl group. It is called 1,2 methyl radical shifting is occur, and due to this shifting, my dear students, you can get the tertiary carbocation, and we can see here molecule is formed CH3, C, CH3, CH3, CH, and CH3 and CH3, and positive charge develop on this carbocation. My dear students, this is the tertiary carbocation. When this tertiary carbocation are formed, these OH minus ions are attached with this tertiary carbocation, because tertiary carbocation is more stable than secondary carbocation. So my dear students, product is formed, that is CH3, COH, CH, CH3 and CH3. Now my dear students, this product is final product you can get. You can see here, and it is the major product. So you can see this product where is present, the CH3, CH3 and OH is present here. You can see here, that is the answer A. You can get the major product in answer A, CH3, CH3, COH, CH, CH3, CH3. So major product is the answer A. So my dear students, concept is that when methyl radical shifting is done in the molecule, then you must be methyl radical shifting you can done, and this secondary carbocation is converted to tertiary carbocation. This methyl shifting will be occur because this secondary carbocation is tertiary carbocation conversion of this carbocation, and you can see a tertiary carbocation is always more stable than the secondary carbocation. So my dear students, this is the answer, and you can get the product. Now we can see here question number 38. Which of the following compounds will exhibit cis transgeometrical isomerism? What is the concept of this question, my dear students? Here you can see the concept. Number 1, my dear students, those molecules in which double bond present between carbon and carbon atom. Those molecules in which double bond present between carbon and carbon atom, and in each carbon atom attached by two different groups, and each carbon atom attached by two different groups, then geometrical isomerism then geometrical isomerism is present. So, my dear student, this is the concept, and in this concept you can see here, and in this concept you can see here, in this concept those molecules in which double bond is present. Here you can see here butanol, double bond is not present, that is why it is not answer. 2-butene, here you can see the ine, ine means you can see here triple bond is present, so this is not answer. Here 2-butenol, yes, butene, ene means here ene, double bond is present, but in with double bond in each carbon atom is by 2 different groups. So, here when you draw this structure 1, 2, 3 and 4, here 2-butene means double bond is present on the second carbon atom, so it is called 2-butenol means OH group present on first carbon atom. So, this is CH2, here CH 1, 2, 3, 4, here this is called CH3. My dear students, here you can see this CH, CH3, CH, CH2OH is present. So, you can see here 1, 2, 3 and 4 carbon atom, 2-butenol. So, this compound is also shown because here this H and H are present, and here CH3 and CH3 CH2H is present. So, my dear students, it is also show this geometrical isomerism. So, answer is C, and you can also see here 2-butene 1, 2, 3 and 4. Here this double bond is present on second carbon atom, that is why this CH3 H and CH3 means 1, 2, 3, 4. It means here, my dear students, geometrical isomerism also show in D option also. So, you can see here you can get the 2 options, 2-butenol and 2-butene. If you get this is 2-butanol, if double bond is absent, then you can get only answer D, but here ene is present. So, ene is present, so means double bond is present. Number 1, double bond present. Number 2, different groups are present in single carbon atom, you can see here, and in same side same groups at least present, and this is also present. So, in geometrical isomerism all conditions are fulfilled. So, my dear students, C and D options are correct in these options. If misprinting is there, I hope, because if you can convert this to butanol, here you can convert this to butanol, this E is replaced by this A, then my dear students, this is not answer. Why? Because when you draw the structure of 2-butanol 1, 2, 3 and 4, this is OH group, here CH3, here H, here CH2 and CH3, you can say here double bond is absent. So, absent the double bond, this compound is not give this geometrical isomerism. I hope this is 2-butanol, so answer is D, and if you give this 2-butanol, then you can get answer C and D. This is the concept and the reaction, my dear students. Now, we can go to the question number 39. Here you can see, my dear students, this is the question number 39. CH3, CH, CH3, CH double bond, CH2. Here you can see the HBr, here H plus and Br minus. My dear students, this is the same question in which carbocation is present, and when this carbocation is present, it means shifting secondary this is the secondary carbocation, it means shifting is there, shifting off, shifting of 1, 2 hydride ions are there. This is the hydride ions, this is a shift we can form the structure of this secondary carbocation CH3. Here you can write this H, and my dear student, this is the CH3, here this is CH, double bond CH2, here this is minus charge is percent, here you can get the plus charge. Now my dear students, this carbon atom is a secondary carbon atom. Secondary carbocation is present. So, this hydride ion is shift to this carbocation, and this type of shifting is called here 1 carbon, 2 carbon. So, it is called 1,2 hydride ion shifting, 1,2 hydride ion, 1,2 hydride ion shifting. Now, my dear students, when 1,2 hydride ion shifting, then you can get the product CH3C plus CH3, this CH2 and CH3. Now, my dear students, Br is added on this tertiary carbocation. This is called tertiary carbocation, and my dear students, this tertiary carbocation is more stable than the secondary carbocation. Because, my dear students, tertiary carbocation is more stable than the secondary carbocation, that is why, my dear students, this bromide ion go to this tertiary carbocation atom, and you can get this product. My dear students, where this product you can see, this product is present in this product is present in which compound? CH3 here you can see here, this is present in D option, CH3, CBr, CH2 and CH3. So, my dear students, when you can go to question number 39 and you can get the D option, and this question is asked in NEET 2008. Now, my dear students, we can go to the question number 40. Which of the compound with molecular formula C5H10 yields acetone on ozonolysis? Here, my dear students, what is the concept of this question? When alkenes are present and these are ozonolysis mistakes with ozone and then zinc and water, then this double bond is broken to formation of aldehyde, 2 molecules of formaldehyde. This is our first action. When you can see, my dear students, second action, CH3, CH double bond CH2, and it is reacts with ozone and zinc and water, then this double bond is broken and you can get 2 molecules. First is acetaldehyde and second one is formaldehyde molecules. In this way, you can see the compounds. Now, we can see here, this is the basic concept. Now, in this question, C5H10 is present, means it's alkene, 5 carbon atom alkene, 1, 2, 3, 4 and 5. And this alkene, 5 carbon atom alkene, you want get this acetone molecule. First of all, my dear students, you draw the structure of acetone. This is the trick to get the result. First of all, you draw the structure of acetone. This is the acetone molecule, my dear students, and you can draw the 2 molecules of acetone, because here only acetone molecules. When this alkene is present, propene is present, then you can get acetaldehyde and formaldehyde. And for this ethene, you can only get formaldehyde or CH2O. In this way, my dear students, when this question asked only acetone, another product is not, name of the other product is not given. So, my dear students, you can get that alkene which only acetone is present. Then acetone is only present, my dear students. I give you small trick to obtain the answer. Here my dear students, this oxygen, two oxygen atoms are removed, and this 1, 2, 3, 4, 5 and 6 carbon atoms are there, and you can get only 5 carbon atoms. So this is the 1 and 2 carbon atom, these alkenes are present. So my dear students, you can see here CH3, CH3 double bond, CH3 and CH3. This compound is also give the ketones, oxygen, this compound is also give the ketones. But this compound is a 1, 2, 3, 4. This is a 2, 3 dimethyl butene. Here my dear students, here 2 butene is give us, 1 butene is not give us ketones, but 2 butene give us ketone, and here 2 methyl, 2 butene, it means 1 methyl is less, and when you can less this 1 methyl, means you can here remove this 1 methyl, and this H2 is added. So my dear students, you can get the 1, 2, 3, 4, 5. 5 carbon atoms, you get the 5 carbon atom, and hydrogen is 3 plus 3, 6. 6 plus, this is the only one hydrogen atom is here. Why? Because here my dear students, here you can see the double bond. So 1, 2, 3, 4, 4 valencies of this carbon atom is satisfied. So my dear students, this is your compound, because when this compound is broken, then my dear student, you can get the acetone. And which type of acetone you can get? One, you can get the acetone as well as acetaldehyde. But this acetaldehyde is not given, but by these compounds, by the answers, you can get only acetone, CH3, COCH3 as well as acetaldehyde, because here molecular formula is given, that is C5H10, and C5H10 form this type of alkenes, 2-methyl, here 2-methyl, 2-butene. This alkene is called 2-methyl 2-butene. So you can get acetone and acetaldehyde. This is my answer, and answer is my dear student, that is question number 40, answer is D, and this question is also asked in 2007 NEET. Now my dear students, here we can see the question number 41. Here, which one of the following alkene will react faster with hydrogen under catalytical hydrogenation reactions? My dear students, those alkenes are faster in which less concept. Here less alkyl groups, less alkyl group containing alkenes, less alkyl group containing alkenes reacts faster than other alkenes. So my dear students, here this is the first concept. Here you can see 2 alkenes, here you can see 1, 2, 3 alkenes. So answer is this not, 4 alkene, answer is this is not, because here this is the addition of hydrogen with catalytical hydrogenation, means alkenes convert to alkenes. Here my dear students, this is the 2 alkenes are present here, but here 2 alkenes are present in one direction. So here hydrogen, when hydrogen is added in this carbon atom, so these alkenes are produce steric hindrance. Due to this steric hindrance, my dear students, hydrogen is not added with this carbon atom. So your answer is A. Here 2 alkenes, less number of alkyl groups are present, as well as these alkyl groups are far away. So easily hydrogen atoms are catalyze these carbon atoms and form alkenes. So answer is A. Now my dear students, we can go to the question number 42. Reaction of HBr with propane in the presence of peroxide. What is the concept? My dear students, HBr reacts with alkenes, in presence of peroxide to give peroxide effect. Peroxide effect means electronegative part attached to that carbon atom in which more number of hydrogens are present. Here you can see, my dear students, what is the reaction? Propene CH3 CH double bond CH2 reacts with HBr in presence of peroxide. So, my dear students, here this is the electronegative part and this electropositive part. So, my dear students, electronegative part attaches to that carbon atom in which more number of hydrogens are present. So, Br minus ion attaches this carbon atom, and you can get the CH3 CH2 Br. So, this is the product 1, 2, 3. It is called 1-bromopropane, 1-bromopropane, or in common name it is also called normal propyl bromide. So, my dear friends, your answer is, you can go the answer D. D is the correct answer for question number 42. This question is also asked in 2004, my dear students. Now we can see the question number 43. The compound CH3CCH3 on reaction with NaI4 in the presence of KMnO4 gives, my dear students, here what is the reaction? Here you can see the CH3C, CH3 double bond CH, CH3. Here, my dear friends, KMnO4 is the strongest oxidizing agent and NaI4 also a oxidizing agent. So, my dear friends, sodium iodide and potassium permanganate both are act as oxidizing agent. So, both are decompose this molecule, and here oxygen and here oxygens are attached because sodium periodate gives us oxygen. Here this KMnO4 gives us oxygen. So, my dear friends, 3 oxygen atoms are attached and these double bonds are broken. So, my dear friends, you can get the CH3, CCH3 double bond O, plus you can get the this CH3 and COOH. This question is also asked in 2003 NEET exams. So, my dear friends, this is the question number 43. I hope you can get the concept and reaction. Now, we can go the question number 44. In question number 44, geometrical isomers differ in. My dear friends, what is the geometrical isomerism concept? When you can get here this CH3 group, here this is hydrogen, this is CH3 and this is hydrogen. When double bond is present between the carbon-carbon atom, and in each carbon atom you can see here at least one side same groups are present and different groups are present in a single carbon atom. Here A, B, different groups are present in a single carbon atom. My dear students, when same groups are present in a single site, then it is called cis form. And when partial rotation or strict rotation take place, then you can see here CH3 H, here this is H, and CH3 you can see here this is same groups are present in opposite side. So, my dear students, it is called transform. So, cis and transform you can get here, and it is a partial restrict rotation. Due to this restrict rotations, the same groups are present in different side, and my dear student, this is present in a space. So, this is called spatial arrangement. So, you can go the answer C, spatial arrangements of atoms or groups. Here, my dear students, when you can see the position, here you can minutely change that 1 carbon, 2 carbon position of the CH3 in 1 carbon atom, here position of the CH3 present on 1 carbon atom. Position of this are not changed, my dear students, only the here change the groups or atoms of these compounds. Now, my dear students, we can go to the question number 45, and this question is also asked in the 2001 NEET exam. In the presence of alkene from alcohols using L2O3, which is the effective factor, my dear students, what is the reaction? You can see here reaction. This is the alcohol RCH2H, and when heated with Al2O3, and here temperature is must be there 350 to 373 Kelvin approximately, means high temperature is given. This is the approximate temperature I give you, means high temperature is given. Then you can give this OH and H are removed, and you can get the alkenes. It means here temperature is the important factor for this reaction. So, my dear students, you can go the answer B, temperature. Temperature is the important factor for this reaction. So, my dear students, this is the hydrocarbons and basic concept of organic chemistry I give you, and I give you all the concept in which based all questions of NEET are based on this concept. I give you all the concepts. So, my dear students, I hope you can understand well. Thank you very much.